Okay, folks, good morning. So welcome back. Probably around half of you have already done Lab 1 on Tuesday. I do realize that probably a non-trivial percentage of you had some trouble with it. It was perhaps a little bit long, maybe a little ambitious. Nevertheless, that's okay. Don't panic. Everything's fine. What I would say is, as long as you were able to get SSH'd into compute.gall and hopefully clone your Git repository, then I'm okay with that, okay? The other thing is you don't need to stress out about, oh, you know, I have to finish this lab in time by the end or I'm not gonna get a mark. If you show up to the lab, the TA will give you the mark as long as you show that you've done something there, okay? So you don't have to worry. It's not a stressful environment. It's just a place where you can go and practice some things and then hopefully ask some questions if you run into problems. So don't worry if you felt pretty lost in that lab. You'll be fine. You'll have extra practice in Lab 2. We'll be seeing a lot of these commands over and over throughout the course. So don't stress too much about that. What I would say though is I do recommend, if you were not able to complete all of Lab 1, I would recommend, you know, this weekend at home, SSH into Gall and try getting it finished because it is foundational material for doing assignment 1. Okay, so today what we're going to do is get into Linux commands. We will be looking at a lot of the commands that the Tuesday lab folks already took a look at, but we'll solidify that for you. Before we get into that, I want to show you very briefly, well, not very briefly, but I'm going to try and get through it as quickly as possible, how to set up a Linux-like environment on your own laptop, whether you're running a Windows laptop or Mac. I am going to run through that material fairly quickly, just because it's not all that interesting for me to stand up here and say, okay, well, now type this, now type that. You kind of have to go home and just go through the tutorial. But I'll take you through the basic steps in today's lecture, and then hopefully you'll go home and you'll try setting it up and get yourself an environment set up so that you can practice all of this stuff at home on your own laptop. And then you have no excuse not to try Linux. We'll also be talking about remotely accessing Gall from home. We need to talk about some concepts related to the file system, and then we'll get into, I think, around 20 basic commands that you'll use in your day-to-day Linux working environment. And finally, we'll talk about some common keyboard shortcuts. So first things first, this is for the Windows folks. Mac OS folks, you'll be next, so just hang tight. So if you're running Windows 10 or Windows 11, Microsoft has introduced a feature, since 2016, called Windows Subsystem for Linux, which basically lets you install a Linux environment at your fingertips on your Windows system. You can see I just switched to another window on my Windows laptop, and I'm able to, you know, CD around and use commands. I'm able to go to my Windows Documents folder, for example, C users. Documents. I could edit my Windows documents from Linux. I could, you know, edit my Linux documents from Windows. So it just puts a Linux environment at your fingertips and kind of gives you the best of both worlds. You don't have to give up, you know, all of your games and your nice Windows GUI environment, but at the same time, when you need some extra power, you can switch into the Linux shell and you can use all of the Linux commands that are available to you. So I am a Windows user, but I'm using WSL all day, every day for my day-to-day work. It makes me more efficient and more effective. We talked last day about the fact that there are all kinds of different Linux distributions, different flavors of Linux, Ubuntu, Fedora, Debian, and so on. All of those major distributions have distributions that support Windows Subsystem for Linux, so you can sort of install what you like best. And yeah, as I say, it just sort of gives you the best of both worlds. So there's two versions of WSL, WSL 1 and 2. WSL 2 was released in 2019. It runs Linux in a virtual machine on your system. But you don't have to worry about, you know, like in the old days, you might have to start up VirtualBox or VMware Workstation and fire up your virtual machine. And it was kind of heavyweight. It would slow down your system, and it wasn't really well integrated with the underlying Windows system. In this sort of environment, it's a very lightweight virtual machine. You don't have to worry about it. It just runs transparently behind the scenes. You don't ever even know that it's running. And it's still, even though Linux is running in a virtual machine, it still feels like Windows and Linux are very much tightly integrated. Now, the downside to WSL2 is that it does require that your CPU supports virtualization. It also requires that even if your CPU supports virtualization, on a lot of systems by default, that feature is disabled in your BIOS or your UEFI. So you have to, if your CPU supports virtualization, you have to go in and enable that. And we'll talk about that in a few minutes. Now, WSL1 is the predecessor, released in 2016. It does not run in a virtual machine. It's sort of like a translation layer, a compatibility layer. So if a Linux program tries to make like a Linux function call, a system call, WSL1 will serve as a translation layer, translating that from a Linux system call to a Windows system call. Downside there is that not all Linux commands work, and it is a bit slower. So if you can run WSL2, I recommend it. But WSL1 does not require any kind of special CPU. So even if your CPU does not support version 2, you can always run version 1. And we'll cover both. So the first thing you're going to do is you're going to press Control-Shift-Escape on your computer. That's going to bring up your task manager. You go over to this Performance tab, and you go down here and you take a look, is virtualization enabled? If it says that it's enabled, that's great. You're all set. You can install WSL2, you're good to go. If it says that it's disabled, there's one of two possibilities. First of all, that feature of your CPU may just be disabled in your BIOS, in your system setup. Alternatively, your CPU might not support virtualization. So you first want to reboot into your BIOS, try to see if that feature is available and enable it. If you can't find that feature, no problem, you just install WSL1. So again, if you look at Task Manager and it says that virtualization is disabled, you're going to reboot your computer. Now, how you get into your BIOS differs depending on who manufactured your PC. So here on the slide, we have a Dell system. And I don't know if you can see the top right, it says F2 for setup. Okay, so on that Dell system, as I'm rebooting and I get to that manufacturer screen, I would press F2 and that would go into my BIOS setup, into my system setup. Okay? Some systems it'll be F1, some it'll be F2, some use F12, others use the delete key. So you kind of have to pay attention when your system is rebooting. It should tell you what key to press. If you don't know, you can't figure it out, it doesn't say on the screen, reboot your computer. When it gets to your manufacturer logo screen, just start hammering F1. See if that works. It'll either go into your BIOS if F1 was the right key, or it'll go to the Windows logo screen, in which case, okay, it's too late, that was the wrong key, you got to reboot all over again, and now this time you're going to try hammering F2. Try again. If that doesn't work, try hammering F12 or the delete key. Eventually, one of those will get you into your BIOS, okay? I do have a link on the slide as well if you want to, if you need some more help. I've linked to an article on getting into your BIOS. So once you are booted into your BIOS, and just be aware that for each manufacturer, it will look wildly different. So this is a BIOS for a Dell system. What you need to do now is try and find the feature that allows you to enable virtualization. Now, they've complicated things because the name of that feature is going to differ depending on whether you have an Intel CPU or an AMD. It's also going to differ depending on the manufacturer of your motherboard, of your PC. So if you have an Intel CPU, you might see VT, VTX, Intel virtualization technology. It might just say virtualization. So you got to look around. Generally, so for example, in this Dell BIOS, I would be using my arrow keys to move left and right through those top level pages, main, advanced, security, and so on. And I'm going to look through all of those pages to try and find an option related to virtualization. Okay? Here, they've just called it virtualization, so that's pretty easy. So all you would do is use your arrow keys to move down, you press enter on it if it's disabled, and you switch it to enabled. Okay? If you have an AMD CPU, again, it may say virtualization, but you might also be looking for something like AMDV, SVM, or Secure Virtual Machine. So have a look through your BIOS settings. and see if you can find such an option. If so, enable it. And then before you exit out of your BIOS, generally there's an exit page there you can see on the far right. You would go over to that. There's an option then to save and quit. So you want to make sure you save your changes so that feature stays enabled. Okay? So hopefully you're able to find that option. If you have sort of a lower end laptop, if it was, fairly inexpensive, or maybe it's a little bit older, some laptops will have CPUs that do not support virtualization. So you may not find this feature in your BIOS. Again, if that's the case, all is not lost. You just installed WSL 1. So whether or not you're installing WSL 1 or 2, the first thing you're going to do is click on your Start button. You're going to search for Terminal. If you do not find Terminal, I recommend installing it from the Microsoft Store. So there is an app on your laptop called Microsoft Store. Go into it, search for Windows Terminal, and install it. It's a really good terminal program. So I would recommend, once you have it installed, you click Start, search for Terminal, right-click on it, pin it to your taskbar. That just puts it right at your fingertips. That way there's no excuse not to just launch Linux and try it out, work with it every couple minutes a day and get familiar with this stuff. So once you have the terminal icon, you click it to launch it, and you're going to type in WSL space -- install. You're going to get some security pop-ups. You click yes on those, and it's going to do its thing. Now, it has to download a whole bunch of features. It has to download, all of Ubuntu. It installs Ubuntu by default, which again is a distribution of Linux. It's a very popular one. So depending on the speed of your system, the speed of your internet connection, that could take 5 minutes, that could take an hour. Just let it go. It's not frozen. Don't close it. Don't reboot. Just let it do its thing. Eventually, it'll tell you it's done, and it'll say, okay, you need to reboot. Okay? So once it does, you reboot your computer, and it's going to pop up this window here after you reboot. Automatically, that'll pop up, and you can see here that it will ask you to choose a new username. So whatever username you want to use for your Linux account on your Windows computer, you choose it. It'll ask you to choose a password. So type in a password, confirm the password, press enter. When you are typing your password, it will not echo your characters back to you. So you're not going to see stars or anything. You're not going to see what you're typing, but it is accepting your input. Okay? So if you get to this point, you have installed WSL 2, you're all good. You can skip the next section on installing WSL 1. If after you reboot, though, you get this error message, so instead of getting this window where it's asking you to choose a password, if instead you get this error message, all that means is you either didn't enable the virtualization feature or your CPU doesn't support it. So that's fine, we installed WSL 1. To do that, you're going to, again, go Start Terminal. This time, you're going to right-click on it and click on Run as Administrator. Okay? It's going to give you a security prompt. You say yes to that. You're going to paste in this big, long command, and that is going to install WSL 1. It's going to make you reboot one more time. And then after you reboot, you're going to fire up Windows Terminal. You're going to paste in these two commands. WSL set default version 1. We want to use WSL 1. And tell it to install Ubuntu. Okay? And then just as with the WSL 2 installation, it'll do its thing, and eventually it will ask you to choose a username and to choose a password. Okay? And once you've done that, now you've got WSL 1 installed. So a couple of last things then for the Windows users. I recommend within your Windows terminal, open the settings so you can press Control, comma. Change this default profile here to Ubuntu. All that does is when you open Windows Terminal, rather than loading PowerShell, it will by default load up your Linux distribution for you, okay? You can still load PowerShell by selecting the little drop-down menu within Windows Terminal, but by default, it'll load Linux for you, which is kind of nice. Change the default terminal application to Windows Terminal, then go over here to the Interaction tab. And I recommend turning this on, automatically copy selection. It's just kind of a nice thing to copy something from the Linux command line to your clipboard. You just have to select the line, and it'll automatically put it on your clipboard. So save that up, and then you're going to close Windows Terminal and relaunch it. When it relaunches, it should automatically load up Linux for you. So some last things you're going to do is just get your system set up with the software that we're going to be using in this course. So first of all, you have to update what's called the package list. So you're going to paste in this command. It'll ask you for the password that you had selected for Windows. So you type that in, you press enter. Sorry, not for Windows, for WSL, I should say. So you'll put in that password, you'll press enter, it'll update the package list, and now you're going to type in this big long command, which just essentially installs a C compiler. The C compiler we'll be using in this course, it's called GCC. Okay, so that will install that for you, and it will also install some of the Linux editors we'll be looking at likely next week, so NeoVim, Emacs, and Nano. And then I just recommend pasting in these commands. All they do is, NeoVim is a newer version of another Linux editor called Vim. I think it's better, a lot of people think it's better. All this does is when you type Vim, it'll actually run NeoVim instead. So if everything succeeded, once you get to this point, you should be able to type GCC space -- version, and you should get something like this. It doesn't matter if the version number is a little bit different. As long as you see that GCC gives you some sort of information here, and it doesn't give you an error, then you're good. You've got a C compiler installed, you've got a Linux environment installed on your laptop, and you're all set to go. Okay? So I recommend try this out. You know, this weekend, take a little bit, try it out. It'll just make it easier for you to practice. It'll make it easier for you to work on your assignments, and you know, just give you some extra practice at the Linux command line. Okay, for you Mac users out there, you already use a Unix system every day. All right, your Mac OS is based on BSD Unix, so you're already using Unix every day or a Unix-like operating system. You just need to learn how to use the command line. So what you can do is click on the Launchpad in your dock there, or press your little Launchpad key on your keyboard. You type in terminal in the search bar, you click on terminal, and lo and behold, we've got the terminal. This terminal, however, is not good. I used Mac for many, many years, so I am quite familiar with Mac. This is just kind of a garbage terminal application. I don't recommend it. I would recommend instead that you install something called iTerm2. It's a really good, popular terminal for Mac. So you go to iterm2.com, you download it. You're going to go to your downloads folder. You're going to drag iTerm into your applications folder that installs it. Then you're going to go into your Launchpad again. I would recommend dragging iTerm from your Launchpad into your dock. Again, it just puts it at your fingertips. It's sitting there in your dock, enticing you. Come try Linux every day. Okay? But that's up to you. And then once you've got that either in your dock or from the Launchpad, click it to launch it. First time it launches, it's going to give you a warning. You click on open, and there we go. We've got iTerm installed. Just a couple of handy things. To copy a line of text from iTerm, you're just going to select the line and click it, and it will automatically put it on your clipboard. You can, of course, use the standard Command-C as well. If you want to paste a line, if you've got a mouse that has a middle button, I believe you can middle click, if I recall correctly, and it will paste it in. Alternatively, you just use the standard Command-V to paste. Now, when you launch iTerm for the first time, it should pop up this little dialog box asking you to install the command line developer tools. You do want to do that, so click install. What that's doing is just installing like a C compiler and a bunch of other tools that will be useful, so absolutely tell it to do that. If it does not pop up that message, at your terminal, you're going to type in xcode select -- install, and it will then pop up this message, and you'll click install. So it will ask you, to accept a license agreement. You click accept. It'll do its thing, let it go, and then once it's done, you can type in which GCC. That's just saying, is there a program on this system called GCC, and if so, where is it? So if it's installed correctly, you will see it'll say /user/bin/GCC. And then you can type GCC -- version, and oh, it's not GCC, it's Apple CLang. So Apple has decided in their infinite wisdom that we know better than you, so they have actually symlinked GCC to their preferred compiler, which is CLang. Okay, so when you type GCC, it actually runs their compiler called CLang. Now, in all honesty, for what we're going to be doing in this course with C, that's totally fine, most likely. However, because we are going to be marking your assignments with the GCC compiler, we're going to take all your assignment code and we're going to compile it with GCC in this course. I would recommend, just to be safe, install GCC. So to do that, you can use an excellent package manager called Homebrew. And I'll show you how to install that, and then using Homebrew, you install GCC. So you're going to go to brew.sh. On the main page, there's this big long command. You can either copy it from there, or you can copy it right out of my slide here. Paste it into your terminal. It's going to ask you for your Mac password. It just needs that because to do the installation, it needs to switch to the root user, to the administrative user on the system. So type in your Mac password. Again, for security, it is not going to echo the characters you are typing, but it is accepting your password. So type in your Mac password, press enter. It's going to do its thing. At the end of installation, you're going to see this next step section. Sorry, it's not on the screen, but you will see a next step section, and it will give you basically these two commands here. I edited this one to make it a bit more generic, but it does the same thing as what Homebrew will tell you. So you can either copy and paste the commands that Homebrew gives you, or copy and paste them right out of my slides. And once you've done that, Homebrew will be installed. You can now type in brew install GCC, and that will install the GCC compiler. Okay, that might take a little bit. I think on my system it was done in 2 minutes, but if you have an older Mac, it's possible that it might have to actually compile GCC, in which case that might take quite a while. I'm realizing now that I forgot to tell you how to install the editors that I told the Windows folks how to install. So in addition to brew install GCC, you would then type in brew install NeoVim. So we saw earlier, we have in the Windows section, I'm telling them to install NeoVim, Emacs, and Nano. You would just type in those same things for brew. You would say brew install NeoVim, press enter, brew install Emacs, press enter, and brew install Nano. And all of those should be installable via Homebrew as well. Okay, and I'll update those notes later on. A couple of last things then for the Mac users. Copy and paste these commands in once you've got GCC installed. All that does is Homebrew installs GCC as GCC-13. So instead of having to type GCC-13 every time you want to use it, this creates what's called an alias. So it just says, okay, when I type GCC, I want you to actually run GCC-13. Okay, lastly then, you type in GCC -- version, and you should see something like this. Again, the exact version number does not matter for our purposes, as long as you see that it's not saying CLang anymore, it's saying GCC. Okay? Any questions before I move on about that stuff? We're good? Okay, so I recommend try that out at home. You know, take half an hour on the weekend and try it out. Try to get a Linux environment set up. It will definitely help you for this course. And you may just find that it's going to help you in everything else you do in your computing career. So let's talk about remote access. First things first, I will give you an overview of our undergraduate network. It is called GAL, which is the Graphics and Undergraduate Laboratory. That's a really old historical name, I think from the 80s or maybe even beyond. But the bottom line is nowadays it consists of our compute server, compute.gal.csd.uwo.ca. That's the server that, well, if you've done Lab 1 already, you SSH'd into that, and you're able to work at that and work on assignments and code on it if you like. It's available for general purpose use. We also have 5 labs, 4 Windows labs, and of course our Linux lab, MC244, where you have your weekly lab. So compute.gal, as I say, is a shared server where anybody can SSH into it. Sorry, we'll talk about SSH in a minute. Anybody can connect into it. and they can code on it, they can run programs, they can test their code and so on. You access it with the SSH protocol, also known as Secure Shell. So this is a text-based protocol. It's not graphical. You're not going to get a nice pretty window popping up. I realize that for people who are new to Linux, that's kind of jarring. You're thinking, oh, this is boring, this is ugly. Try to resist the urge to feel that way. Just think, okay, this is different, but there must be some reason why all these old people really like this stuff. It's not just because we're old and we don't like pretty, shiny new things. It's because at the command line, when you're not dealing with pointing and clicking and using your mouse, you can do things a lot faster once you get to know this stuff. For many, many tasks, if we sit and have a race and you're sitting there pointing and clicking and trying to click around, I'm just running rings around you at the command line, typing commands. So try to embrace it rather than thinking, oh, this is so boring and ugly, okay? SSH is an encrypted protocol, so anything you type over it is encrypted, so you don't have to worry if you're typing your password. Nobody can listen in on your connection. It is fully encrypted. And it allows you to log in and work at a remote Linux system. So we say that you SSH into a server. It is remotely accessible from off campus. Most of our systems on our network are not, but you can SSH in from home to compute.gall, and then from there you can use it as kind of a jump box. So let's say you wanted to SSH into one of the lab systems in MC244. What you can do is first SSH to compute.gall, and then from there you can SSH into one of the lab systems if you wanted. For the most part though, people will generally just SSH and work on compute.gall. So, some terminology before we get further into things. I think most of us are familiar with the notion of an account. An account represents either an individual user. It could also be what we would call a system entity. So some software, like if I install, I don't know, the MySQL database, it will create a MySQL user that is used to run that program on a computer and to keep it kind of isolated. So it can either be a user or just, we call it a system user or a system entity, okay? The account, of course, establishes a unique identity for you on a given system. And it will consist of some sort of public identifier, generally your username, some metadata about you, like your name, what shell you use, that kind of thing, and then one or more secrets, so your password, maybe you have a security token. I don't know if you folks can see, but I've got this tiny little USB device plugged into my USB port. That is a security token, okay? Biometrics, like your fingerprint or your retinal scan, that sort of thing. Now, on every Linux and Unix account, we have a special account called root. That is the administrative account on the system. It's got full privileges. Okay, it's similar to, on Windows, we call it administrator. On Unix, Linux, and Mac OS, we call it root. The best practice that sort of everyone kind of agrees on is that, for the most part, when you're using a Unix or a Linux system, you should stay as a non-privileged user, a regular user account most of the time, and then only switch to root when you need to do something that requires root privileges. So if I need to install software, I will use a command called sudo, S-U-D-O. You might have seen that earlier on. We were saying sudo apt install when we were installing WSL. And what that does is it says, okay, for this command, for the apt install command, I want you to switch to the root user, sudo, or sudo, I guess it actually is pronounced, but I pronounce it sudo. So best practice is don't stay as root, because as root you have full control over the system. You can really screw things up, especially as a beginner. You do not have root access on our systems. So some people were messaging me last night saying, I'm having trouble with Lab 1 and I did some Googling and somebody told me to type like sudo mv blah, blah, blah. You can't use sudo on our servers because you don't have access to switch to root, okay? Yeah. Now, authentication is the process of, okay, I claim that I'm the user Jeff, I have to somehow prove that. So I might prove that using something that I know, like a password. I might prove it with something that I have, like my security token or the Duo mobile app. I think all of you are familiar with that, when you log into a Western system, you have to tap accept on your phone. It might also be something that you are, or something that belongs to you. My fingerprints, my retinal scan, that sort of thing. So authentication, proving that I am who I say I am. Authorization, on the other hand, is, okay, you're into the system now, you've authenticated, we know who you are, you've proved your identity. Now we want to figure out, well, what are you allowed to do? Okay, what files are you allowed to change? What commands are you allowed to execute? Are you allowed to modify the system config or not? That kind of thing. We're going to see later on in this course a few of these things. File permissions, so I can say, you know, everybody is allowed to edit this file, but only I'm allowed to edit that file. You can create user groups and say, all right, well, this group of students is allowed to run this command, but they're not allowed to run all of these other commands. And then there's some more advanced features like access control lists and whatnot. Probably won't get to those in this course. So key thing to understand here is the difference between authentication and authorization. Authentication, prove who you say you are. Authorization, what is this user allowed to do on the system? So then, to authenticate on Gall, you are going to use your Western username and password. Note that everything on a Linux system is case sensitive, okay? So you're going to type in your username in lowercase letters, and whatever case you use in your password, you need to make sure that you type it exactly, okay? A lowercase p is not the same as an uppercase p. On a regular Linux system, to change your password, you're going to use this passwd command, password. Okay, it'll ask you for your current password, it'll ask you to confirm your new password twice, and that will change your password. Best practice in this day and age is obviously longer is better, so choose at least a 12-character password or more. You generally want to have a mix of upper and lower and digits and symbols and whatnot. And if you really want to be secure, avoid using the same password across multiple systems. So I use a password manager, and what that allows me to do on every website that I log into, I can have this random string of 32 characters or whatever I choose. And what that means is that even if my password on one site gets broken, it doesn't allow an attacker now to log into any other sites using that password. So if you want to be, you know, if you're ultra, well, I don't want to say paranoid because it's a good practice. But if you want to be ultra secure, you want to try and use different passwords across every system. Now on Gall, you cannot change your password because we use, of course, your Western password. So the password command will not work. If you want to change your Western password, you have to go to identity.uwo.ca. So to SSH in, if you're on Windows, you're going to click on Start. You're going to either search for Command Prompt or PowerShell, or hopefully you have Windows Terminal installed and you followed the tutorial at the start of this lecture and you've got WSL installed. So just fire up WSL and you're going to type in SSH, whatever your Western username is, at compute.gall.csd.uwo.ca. Okay? Make sure that you don't forget the username. Sometimes people forget to put that in. They just type in SSH compute.gall. And what that does is it by default will send whatever your username is on your system. So on my system, my username is Jeff. My username on the server is not Jeff. So it will not let me log in because it's trying to log in as the user Jeff. Please don't actually type in username, okay? Make sure you replace it with your Western username. I know that seems obvious, but I have to tell you that I manage the science help desk here at Western, and every semester we get a few users who will open a ticket and say, yeah, I was trying to log in and it's not working for me. And so, you know, we say, okay, can you send us a screenshot so we can see what's going on? And invariably, a few of them will have typed actually literally SSH username at compute.gall. So please replace it with your actual Western username. So you type in SSH, whatever your username is, at compute.gall. The first time you connect to any Linux system, you're going to get this big long warning. All that's doing is SSH is saying, hey, I haven't seen this server before. Are you sure that you trust this server? So all you do is you type yes, you press enter, and you won't see that again for that particular system when you try to connect to it next time. It then asks you for your password. You type in your Western password and you press enter. Again, it's not going to echo those characters back to you, okay? It's not going to echo your password back to you. Again, every semester we get a few people opening tickets saying, yeah, I was trying to log into Gall and I got to the point where it asked me for my password and then it just hangs. And so it is accepting your input. It's not going to echo it back to you, because if I were looking over your shoulder and if it were to like print stars or something while you're typing, I could then see, okay, that person's got an 8-character password. That makes it that much easier for me to crack your password if I know the exact length of it. Okay, so it will not echo your password characters to you. You're supposed to laugh at those old tired memes. Come on, wake up. So once you have typed your password, you'll see this big long message called the message of the day, and then we get to the Linux prompt. Okay, you're now logged in, you're all set to go, and then you can just type exit and immediately log out. No, I'm kidding. But exit is how you log out. Now, if you SSH in and it asks you for your password and then it says permission denied, please try again, that either means that you forgot to enter your username, you entered the wrong username, or you typed your password incorrectly. So check it out, make sure you're typing everything properly, try again. Another possibility is that it could be if you added this course late, my team has not received your enrollment yet in our database, so our systems have not automatically created your account. I don't think anyone is in that situation. I manually went and made sure that everyone over the weekend had accounts, but yeah, if you're not able to SSH in, let us know through OWL, send us a message through the OWL messaging feature, and I can take a look at that for you. Contrary to what it says on the slide, don't wait 7 days, because you have obviously labs and you have an assignment due next Friday. So do not wait 7 days. Let us know as soon as possible. Now, alternatively, if you try to log in and it doesn't even ask you for your password, it just says connection closed by remote host. What that means is that for whatever reason, whether you typed your password wrong or the wrong username, you had too many failed login attempts. So it says, oh, this person is trying to hack us, and it firewalls off your IP address for an hour. So you have to wait an hour and connect back in after that. The other day, when a few people in the lab actually got themselves locked out for an hour, I lowered that to 10 minutes. I don't want to lower it to 0, because we get tens of thousands of attempts every single day. People just like bots trying to brute force attack our servers. So we need to make sure that we have some protections in place. So I lowered it to 10 minutes for now, until everyone's at least gone through the first week or two of CS2211 and we've figured out all of these problems. So if you're in the lab and it suddenly says connection closed by remote host, just wait 10 minutes, it'll let you back in. Okay, before we talk about Linux commands, we need to look at some file system concepts just to make sure that we understand some of the concepts and terminology. So hopefully we're all familiar with the notion of a file. Obviously, we have our PDF files, our, movie files, MP3 files, so they contain our data. A file, of course, has a name that allows us both to refer to it. So if I'm typing a command, I can refer to that file by its name. And it sort of reminds me of its purpose usually. Resume.pdf is obviously my resume. Now, part of the file name is called the file extension. That's the .pdf. That hints at the file's type. Now, on a system like Windows, the file extension is generally required, whereas on Linux, you'll find many files do not have file extensions at all. It's not a requirement in Linux. Directories, then, are a means of organizing our files. They're also called folders on other operating systems. We call them directories in Linux, okay? So they can contain files or other directories, also known as subdirectories. File system, then, is simply the collection of all of our files and directories on a system. And as we'll see in a moment, it is organized into an upside-down tree structure where you have the root directory at the top, and then that's got subdirectories, those directories have subdirectories, and so on. Now, one directory on the system is a special one. It's called our home directory. And when you log in, you start out in your home directory. So on Linux, that will generally be under /home/ whatever your username is. On Windows, that's generally c:\users/ whatever your username is. And on Mac OS, it's going to be /user/your username. Now, on a Linux or a Mac OS system or any Unix-like system, you can use the tilde character. So that is the key. If you hold down Shift and you press the key to the left of your 1 key, you should see it inserts a tilde character. That expands to /home/whatever your username is. Okay, so it's a way to refer to your home directory. Alternatively, if I want to refer to someone else's home directory, I type tilde and then whatever their username is, and that expands to /home/whatever their username is. Okay, and then finally, a path is essentially the unique location of a given file or directory in your file system. So, if I have my resume, somebody might ask me, well, what's the path to that file? And I would give them the full path to get to that file within the file system, starting from the root directory, /home/jeff/files/resume. Okay? Between each component of that path, we have a path separator. On Linux, that is the /. On Windows, that's the \. Okay, so just a slight difference there between the two systems. So this is sort of a sample of what a Linux file system might look like. At the top, you've got the root directory. So we call it that's /, but it's also called the root directory. Under that, we have a bunch of subdirectories, bin, etc, home, and so on. So we say that, for example, bin is a subdirectory of the root directory, and we say that the root directory, or / is the parent directory of bin. Home is the parent directory of Henry, that sort of thing. Okay? You're going to read these paths downwards, starting from the top, and separating them by the path separator, by /. So Henry's home directory would be /home/Henry. Root's home directory is /root. Java, we have a file Java here. It's located in /user/bin/java. Okay? That's the full path to the Java binary on that computer. Okay, a few more bits of terminology. A current working directory, hopefully obvious. It's the directory you're currently in on the system. Subdirectory, we said, is a directory that is contained within another directory. So in other words, it's the directory one level down in the file system tree. The parent directory then is the directory one level up in the file system tree. Okay. Now, each directory in the file system contains two special references. Dot refers to that directory itself. We'll see why that's important later. ... refers to the parent directory of wherever you currently are located. And we'll also see why that's important in a bit. Now, when we talk about paths, we have to understand the difference between an absolute path and a relative path. So let's say that I want to access file 3 here, and I'm currently located in /home/abby/temp. So I can reference that file 3 by starting from the top of the file tree. I can say /user/bin/file3. Okay, that's the full path to that file. If I am instead in /home, again, I can access that file by saying /user/bin/file3. So no matter where I am located currently on the system, no matter what my current working directory is, I can always access a file by specifying its absolute path, okay? The complete path to that file or directory starting from the root. So if you're looking at a path and you're not sure, is this an absolute path or a relative path, you just say, does it start with a /? Or does it expand to something that starts with a /? In which case, you would say, yes, it is an absolute path because it's starting from the top of the file system. By contrast, we can have relative paths. So again, we want to access file 3. I'm in this temp directory here. I could say ... because we said ... is a special reference in every directory that refers to the parent directory. So I can say ... ///user/bin/file3. Okay? if I'm in home, I can say /user/bin/file3. So you can see that this time you're expressing the path relative to your current directory, to the current location. Okay, and so a relative path is exactly that. It specifies a path to a file or directory relative to where you currently are, and it will change depending on where you are in the file system. The relative path to file 3 is completely different when I'm in this directory than it is from when I'm in the home directory. Okay? So just a few more examples here to sort of drill the point home. If I'm logged in as the user Abby, and I'm in /home/Abby, that's my current working directory, and I want to access file 1, I can use the relative path temp/file1. I could say ./temp/file1. Again, we said that a single dot refers to the current directory, so I could say ./temp/file1. Alternatively, I could use an absolute path. I could start from the root and say /home/Abby/temp/file1. And of course, before we said that the tilde character expands to /home/Abby, so I could also say ~temp/file1. Does that make sense? Okay. If I wanted to access file 2, again, I could use a relative path, /nora/file2. Okay. Alternatively, I could use an absolute path, /home/nora/file2. Or again, we said before that if you want to reference another user's home directory, it's tilde and then their username. So I could say tilde_nora, which expands to /home/nora, and then /file2. Finally, as we saw, if I want to access file 3, and I'm in Abby here, I would say /user/bin/file3, or I would just do /user bin file3. So what you choose, whether it's relative or absolute, is going to depend on how far away that file is or that directory is that you want to reference, how far it is from you in the file system. If I'm in the Abby directory and I want to access file 1, I'm not going to type in /home/Abby/temp/file1. I'm just going to say temp/file1. But on the other hand, you know, if I'm in this temp directory and I want to access file 3, that's way over across the file system. So I'm not going to type in /////. I'm just going to start from the top and say /user/bin/file3. Make sense? Okay, let's take a 10-minute break, and we will come back and start looking at Linux commands. Okay, so we're going to go through, I think, around 20 basic commands that you're going to use in your day-to-day Linux career. There we go. So before we do, just a quick word on the prompt. The prompt is, it looks like what you see here. It's what you type your commands at, okay? This will be the default prompt you'll see on most Linux systems. Your system administrator might have configured and customized it. It might look totally different than this, but this is the default on a lot of systems. And it's designed to sort of give you a fair bit of information just at a glance. So first of all, it's going to tell me who I'm logged in as. And you might be thinking, well, why wouldn't I know who I'm logged in as? I know who I am. If I'm in a system administrator and I'm logged in to 10 different systems, some of those I might currently be logged in as root, some I might be logged in as my own user account. So it gives me an at-a-glance view of who I'm currently logged in as. Same with the host name. What system am I currently connected to? Again, I might have 10 different tabs. I'm SSH'd into a whole bunch of different systems. It's easy to forget which system is associated with which tab. Where I currently am on the system. So this will generally show the last directory in the path. In this case, I'm currently located in my home directory because I see a tilde there. And then finally, the prompt character, it sort of gives me a hint as to what privilege my account has. Am I currently logged in as a root user, or am I an unprivileged user? So the reason why that's important is that on some systems, you might not have this big, long prompt. You might just see a $ for your prompt. Okay, and you'll see that in some of my notes as well. If you ever see at the beginning of a line a $, that's the prompt character, okay? I don't want you to actually copy and paste that as part of your command. I'm just showing you an example of the prompt character whenever you see that. So the reason why the prompt character is important is that, again, it might not show your username in the prompt on whatever system you're on, and you want to have some sort of indicator. Am I currently logged in as root? In other words, do I need to kind of be careful because I've got all the privileges over the system and I could really screw things up if I make a mistake? Or am I logged in as an unprivileged user? So we're going to talk about what shells are a little later in this course. The shell is just when you SSH into a system, or when you log into one of the MC244 systems, and you type a command in the terminal, the shell is the program that actually executes your command. There's different shells like bash and Z shell and C shell and so on. Not important for our purposes right now. Suffice it to say that in some shells, if you see a $, that means that you're an unprivileged user. If you see a %, that also generally will mean you're an unprivileged user. But if you see a $, that generally will mean you're currently logged in as root, so just be careful, okay? However, your sysadmin might have changed things and for some reason did not stick to that convention. So it's not a foolproof way, but it is sort of one indicator, and that's generally the convention that is used. Okay. Let's dig in. So displaying the current username. Again, well, let's get SSH'd in first. I didn't show you that before. So SSH compute.gall. Can everybody see this okay? Is the text big enough? Do I need to make the background light? Are we okay with this? Good? Okay. So I SSH in. You would normally be asked for a password. I use something else called public key authentication, so that's why it didn't ask me for a password, but rest assured, I did actually authenticate. It's just I'm doing it a different way. Okay, so when I log in, again, let's pretend that my username was not in my prompt. If I wanted to know who I was, I simply type who am I, and it prints my username for me. Sometimes I might want to see who's online. Maybe somebody calls the help desk and they say, you know, the server's really slow today. One of the first things that we will do is SSH in and type who. And that will tell me all of the users currently logged in. This isn't important. It's like their virtual terminal. It doesn't matter for our purposes. When they logged in, I should say, and what IP address they came in from. So a fair number of users on the system today. Okay, so that's the who command. Now, if I want to just filter the output of the who command just to me, I can say who am I? And that will just show me my line from the who command. Okay, now that's in contrast to who am I? Who am I is the who am I command. This one is the who command, and I'm passing the parameters am I to it. Okay, so these are called parameters. If I say, like, I don't know, we'll see the ls command in a bit, ls-l. That's me saying I'm running the ls command and I'm passing it the parameter -l, okay? So when I run this, who am I, I'm running the who command, I'm passing the parameters am I. Okay, so that's the who command, shows you who's logged in. Now, this is probably the most boring one, the man pages. So on a Linux system, there are things called man pages, manual pages. They give you help about commands, about C functions, and so on. In one of the courses I taught, we get our instructor evals, of course, at the end. And one of the comments from one of the students was, he expects us to read man pages. Nobody reads man pages. Now, what that tells me, and not to be condescending, but it tells me that you're a second-year computer science student. People do use man pages. They do. They're not the kinds of things that, you know, you sit down for like a long extended period of time and read them cover to cover. You use them as a really quick reference to look up, what was that option again that I can pass to ls? And so you quickly look at the man page for ls and you find that option, okay? Because a lot of the time, it can be a lot faster just to quickly look at the man page and stay in your terminal rather than switching to a web browser, going to Google, searching for the ls command, finding a result, and then reading that page. If I just need to quickly remind myself of something, it's a lot faster to use the man page. So it's useful to know how to use it, and it's useful to take a look at the man page for a command. So if I want to take a look at the man page, let's say for the who command, I can type in man who. So man, whatever the command name is. The top will give you a brief description of what the command is all about. We have the syntax. It's not really important that you understand this. Suffice it to say, if you see something in square brackets, that means it's optional. If you see an ellipses, that means or more. So what this is saying is you can have 0, because it's in square brackets, 0 or more options, okay, that I can pass to who. And then this is saying optionally, I can either pass the name of a file or I can pass 2 arguments. What were those 2 arguments that we saw? Am I, right? It doesn't care what arguments you pass. You just pass any 2 arguments and it will give you the same output in this case for this command. So I could say, who am I? I could say, who mom likes. And it doesn't matter, ABC, 1, 2, 3. In this case, if you pass it any 2 parameters, it will have the same output. Now, next, it will generally show you all of the arguments, all of the options that you can pass. So, I don't know, you can print a header. So, generally, most commands will have the short option and the long option. Which one you choose depends on your personal preference. I like to often use long options because they're easier to remember for some commands. For other commands like ls, where I need to really type things quickly, I always use short options. So it kind of depends on just your personal preference. If you want to search through a man page, what you're going to do is type in /, and you can see down in the bottom left here, I now have a slash there, and now I can type whatever keyword I'm looking for. So I don't know, let's say I'm looking for login. So some option related to login. I press enter and it takes me to the first result for login in that man page. If I press N, it goes to the next result. And okay, I've got an option -- login that allows me to print the system login processes. I don't know, let's see, boot. Okay, it's not found. I got to go back up to the top. Let's try that again. There we go. Now I see, okay, there's the option for boot. Okay, so / and then a keyword, press enter, and that will allow you to search. If I want to exit, I press Q, and that gets me out of the man page. So now I can say, okay, I looked up the option I was looking for. I wanted to see when the system's been rebooted. Now I know I can type who-boot, and there we go. That tells me the system was last rebooted in the middle of December. Okay, so that is the man command. To move around the man page, you're using your arrow keys. You can also use page up and down. Again, to search, you're using the /, and to exit, you're pressing Q. Now, sometimes you don't know what command you're looking for. Let's say I want to search for all commands related to directories. So I could say man-K for keyword, search by keyword directories. And it gives me this crazy long list of all of this nonsense, most of which is not actually a command. The reason is that man pages are grouped into sections. So section 1 contains all of the man pages for executable commands, commands I would actually type at the command line. Sections 2 and 3 are man pages for C functions. So when we get into C programming in this course, some of those man pages can be useful for that. And then there's a whole bunch of different sections which really aren't important right now. So bottom line is, when you're looking for help with a command, you're going to want to look at man pages in section 1. When you're looking at help with C functions, you're going to want to look at man pages in sections 2 and 3. Now, taking another example, if I were to say, okay, man-K print or printf or whatever, and I'm looking through and I see, okay, I've got 2 man pages for printf. One in section 1, one in section 3. So we said that section 1 is the executable command section. Section 3 is the C function. So this will give me information about the printf command. This will give me information about the printf C function. So to access those, I would say man1 printf. Give me the man page on the printf command. And now I can take a look at all of that. Alternatively, if I wanted to see information on the printf C function, man3, give me the printf man page from section 3. And then now I can see how to use the printf function and take a look through there. okay? If I, again, want to search by keyword, but I don't want to see all of that junk. So before we did man-k, search by keyword directories, and it gave me all this crap that I don't care about. I only want to see man pages from section 1. I could say man-k, section 1, and then whatever my keyword is. And now that's a little bit more of a sane list. I see, okay, copying files and directories, making directories, removing them, and so on. Okay? So those are the man pages. You're not going to use them every day. You're not going to sit down and do some nice light reading and read your man page cover to cover. It's just a quick reference. It saves you a bit of time rather than going into your web browser and searching and trying to find just whatever it is you're quickly looking for. Okay, logging out, we said you just type exit and that logs you out. Listing directory contents, you're using the ls command. So by default, it's going to show you the contents of your directory in columns, okay? You can also pass a path. So which directory do you want to list? If I just type ls, it lists the current directory. If I say, list dir1, that will give me the contents of dir1. That one's empty right now. Let's put something in it. Okay, so that's what my directory tree looks like right now. So if I say ls dir1, it'll show me the contents of that. We said before there's a special reference in every directory, ... which gives me the parent directory. So I could say list the contents of the parent directory. And there we go, that lists my parent directory. If I want to see my directory contents in a list, I would type ls-l. Okay, and that gives me a bit more information. Now, we're not going to be too concerned about what all this means quite yet. This refers to the permissions on a file or directory, and we'll see that a bit later in the course. Hard links, we'll talk about that later in the course. This is the user that owns the file or directory, the group that owns the file or directory. This is the size. Okay, so in this case, these are two empty files. The date that the file or directory was modified or created. No, modified, I should say. And then, of course, the file or directory name. Now, sometimes you'll be looking, so let's say we do ls-l on user bin. And sometimes you'll see this big, long string of bytes when you're looking at the file size. And when it's even longer than that, it sometimes you have to kind of take your mouse and group it into threes, and then you see, okay, it's about 8 megabytes or so. What you can do is tell ls to show you the file sizes as human readable sizes. And to do that, you pass lh instead of just l. Okay, so I can say, show my contents in a list with human readable sizes, user bin, and now instead of that string of bytes, we get 8.1 megabytes or 942 kilobytes or whatever. So those are human readable file sizes. In Linux, if you have a file name that starts with a period, by default, it is considered to be a hidden file. ls will not show it by default unless you tell it to with the -a flag, which is all. Okay, so if I just do ls, I see that. If I do ls-a, I now see, oh, there are my special references that I was talking about before. If I create a file, we haven't seen the touch command yet, but if I create a file, .hello, I type ls. I don't see it anywhere until I type ls-a, and all of a sudden it's there. Now, of course, you can chain options. So if I want to see all files in a list, I could say ls-la. If I wanted, and you can see then I see my hidden files. If I wanted to see all files in a list with human readable sizes, this isn't a good example because I don't have any large files in here. But if I did, it would have showed me their file sizes as human readable. It would show me all files, including hidden ones, and it of course shows them in a list. Okay, so any of these options, you can chain them together to do whatever it is you're looking for ls to do. Okay, displaying the current working directory. So if I don't know where I am currently, yeah, sorry, go ahead. No, so the order doesn't matter. You can do whatever you like. I'm used to doing ls-la. You kind of just, I don't know, in your mind, some order makes sense, and you kind of stick with that for the rest of your career. If, ahl makes more sense to you, then all the power to you. Yeah. Okay, so displaying the current working directory, PWD, print working directory. So if I don't know where I am currently, and I'm all confused, I'm lost, am I in my home directory? I don't know, PWD, okay? That will give you the path to your home directory. Is that an absolute path or a relative path? Absolute, why? Because, sorry? Sorry, I can't hear you. Yes, okay, sure, but you don't always have dots in a relative directory because I could be referencing a subdirectory like, for example, dir1 here. I could just say dir1, and that's a relative path. So what did we say makes something an absolute path? It starts from where? Yep. It starts from the root directory. So if I see a / at the beginning, that's a good sign that we're talking about a root, or an absolute path, I should say, because it starts from the top level of the file system. Anyway, we're getting off on a tangent here. So print working directory gives you the absolute path to your current working directory. Changing directories. So if you want to move around up and down through the file system tree, you're going to use cd, change dir. Okay? I can change, for example, to user bin. And now I'm in user bin. I can type ls. I see all the binaries, all the programs that are located there. I could change to /temp. Now I'm in the temp directory. That's just used for temporary files on a Linux system. If I want to change back to my home directory, I just simply type cd and I press enter. So I was helping someone the other day in the lab, and they were kind of lost. You know, they got somewhere in the file system, and they didn't know how to get back. How do I get back to my home directory? If that ever happens to you, you just type cd, press enter, and you're back in your home directory. Okay? So again, you know, if I'm in this directory here and I see there's a dir1 subdirectory, I want to go into it, cd dir1, cd ... to go to the parent directory, and so on. If, let's say, I go to user bin, and so now I'm in user bin, and I want to change back to the directory I was last in, I could type cd space dash, and that takes me back to the last directory I was in. Okay? Another useful thing to remember. Again, another way to change to your home directory. So we said you can type cd and press enter. I could also say cd tilde, because cd tilde, again, it expands to /home/ whatever my username is. So that will take me to /home/jchance4 in this case. Okay? And there I am. Again, if there was a user named Henry and I wanted to switch to his home directory, I can do the tilde and then whatever his username is. So tilde Henry, and that would take me to his home directory. Okay, if you want to create a directory, you're using makedir, mkdir. So if I want to create a subdirectory, ASN1, I would do makedir ASN1. If I want to create multiple directories at once, I simply separate them by spaces. So ASN1, ASN2, 3, 4, blah, whatever. Okay, and now they're all there. So that's the makedir command. If I wanted to create some nested subdirectories, so if I try typing, I want to create the directory A that contains a directory B that contains a directory C. It's going to give me an error because A doesn't exist, so it can't create B. B doesn't exist, so it can't create C. So what I can do is say makedir-p, ABC. And that says create the parent A first, then create the parent B, then create C. And now it works, and if I look at my tree, I can see I now got ABC. Now I should just mention, you'll see me using this tree command. It is not a standard Linux command. It's not installed on most systems by default. I use it because it makes it a little bit easier when I'm teaching to sort of visualize things, and hopefully you guys can see things a little bit better. You can install it on just about any Linux system. It's not a command you should rely on to be present on any given system that you happen to use. Another use for makedir-p, if I'm writing a script, so we're going to talk about shell scripting later in the course, but sometimes you'll be writing a script and you want to make sure that there's a directory that exists. So let's say I'm writing a script and I want to make sure that dir2 exists. If I type in makedir dir2 in my script will exit with an error because this command failed, because it's saying, hey, you're trying to make dir2, it already exists. What I can tell makedir to do is I can use -p again, and I can say makedir-p dir2. If it doesn't exist, it will create it. If it does exist, no problem, it won't throw an error. Okay, so that's another use for makedir-p. Deleting directories, if they are empty, you can use the rmdir command. Whoops. So if I want to remove the ASN1 directory, rmdir ASN1, and now it is gone. Again, just like with makedir, if I wanted to remove multiple directories at the same time, just separate them by spaces, and then those are all gone as well. If I want to remove a non-empty directory, so let's take a look again at our tree. We have this A, which contains B, which contains C. If I try to use rmdir on that A directory, rmdir refuses to do it because that directory is not empty. So one way to do it, as long as all of those directories are empty along that path, I could say rmdir-p/a/b/c, or not /a, a/b/c. That will say, okay, remove the C subdirectory, then remove B, then remove A. You could do it that way. No one actually does that. They would just use the rm command, which we'll see next. But that is one way to do it. Okay, rm. rm is used for removing files and or directories. So, you cannot remove a directory with rm directly. You can't just say rmdir2 because it's going to say, no, it's a directory. What you have to do is tell it rm-r. So recurse into that directory and recursively delete all of its files and subdirectories. So everything under that tree that is rooted at that directory will be removed. Now, by default on a system, it will not confirm that. It'll just happily delete your files. So you got to be really careful because you might inadvertently delete things. And that's one of the reasons I say, you know, if you were to be logged in as root on a given system, root has permission over the whole system. You could accidentally delete all of your files if you issue the wrong command. So you got to be careful when you're using commands like this. Now, you can see in the example on my slide that it's confirming each one of these choices. The reason in this case is, first of all, I can say rm-ri. I is for interactive. It says, I want you to confirm each deletion before you do it. So if I do that on dir1, then it's going to ask me, do you want to descend into that directory? Yes. Do you want to remove the file A? Yes. Do you want to remove dir1? Yes. Okay. So if I pass -i, it will do that. What I would recommend to you is, as a beginner, you might want to take this command that you see on the slide, paste it into your terminal, and log out and log back in. What that will do is set up an alias so that whenever you type rm, it's actually going to run rm-i, and it will confirm each remove before you remove something. It's just kind of a safe thing to do. I might recommend it if you know, you're just starting out with Linux, but I'll leave that up to you. Now, if you have confirmations enabled, I should say, and you want to delete something and you're positive you want to delete it, and you don't want to worry about any kind of confirmation, you can say rm-rf. So recurse into the directory and force it. So in other words, don't confirm, just delete it all. rm-rf and whatever the directory is that you want to delete. And there, it won't confirm anything, it'll just blow it away. All right, creating some empty files, we can use the touch command. Oh, sorry, go ahead.
What's the difference between -r and -rf?
So -r says you want to recurse into the directory and delete all of its files and subdirectories. -f says I want to force it. In other words, I don't want you to confirm it. So if you had done that alias command that I recommend here, and you aliased rm to rm-i, what that's doing is every time you type rm now, it's going to actually run rm-i, and it's going to confirm every single file and directory that you're recursively deleting. You might not want that. Maybe you have a big directory full of files that you're positive, yes, I want to delete those. I don't want to sit there typing yes for every one of those files. So you can add in F to force it, to say, just delete it, don't confirm all of it. Okay? All right, so the touch command. Oh, go ahead. So this is the classic example of when you have a question like that, try it out, right? Try it out and see, because that's how you learn. So to answer that question, let's try it. So I'm going to say, all right, so you're saying if we have, for example, make-dir-p a/b, and we have an a/c, let's say, and we'll just make a file f1 in there, we'll make a file f2 in there. So let's take a look. We've now got this A directory, it has got B and C as subdirectories, and those each have a file. And you're saying if we do rm-ri on A, and you're saying, okay, we want to descend into A, do you want to delete B? Let's say no to that, and you're saying, will it stop? Nope, it just skips over that one, so it didn't delete B, and now it goes on and says, all right, well, do you want to remove the C directory? So I say yes. And then it goes into the C directory. Do you want to remove file 2 in there? Yes. Do you want to remove C? Yes. And so now, if we take a look at our tree, we see that it deleted the C directory and all of its contents, but it didn't delete B. Make sense? Yeah. Right, it wouldn't remove A because A still has B within it. So yeah. So yeah, that's a perfect example of something like when you're sitting there thinking, I wonder how it's going to work if I do this. Just try it out. That's if you take nothing else away from today's lecture, don't be afraid to log in and experiment, because that's how you really learn this stuff. Okay, touch command. Touch command is used to create empty files. So I can say touch ABC. I've got an empty file now, ABC. How do I confirm that it's an empty file? Do we remember with a command that we've already seen? ls-l. ls-l gives me the file sizes, so I can see it's a 0-byte file. I know it's an empty file. If I want to print a line of text to the screen, I can use echo. So echo hello world. This on its own is not all that useful, but if you're writing a script that's doing a bunch of tasks, sometimes it's useful to print out messages to the screen to let whoever's running the script know what's going on. If I redirect the output of that command, so this is called the redirection operator. We'll talk about that later in the course, but I can redirect the output of one command into a file. So I can say, I want you to print the message hello world, and I want to redirect it to the file 1. And now if we take a look at file 1, we see it's got the message hello world in it. Okay, so that's how, it's a simple way you can write a string to a file. Now be careful with the redirection operator. It will overwrite whatever you have in that file. It will not confirm it. So if I say goodbye into file 1, it's just overwritten file 1, and now file 1 contains goodbye. So you just saw me use cat. Cat is used to display the contents of a file. We can also use it to concatenate files, which is why it is named cat. So if I type in cat and then a file name, it just simply prints out the contents of that file. If I were to have multiple files, so let's say we have CS2211 in file 2, we have hello in file 1. If I type in cat file 1, file 2, if I had 10 files, I could keep going. I can concatenate as many together as I like, and then it'll simply display all of the contents of file 1, all the contents of file 2. And that can be useful sometimes. Maybe you want to join 2 files together, concatenate them. I can redirect them into a third file. And now my file 3 contains the contents of both of those. Okay? So cat is used to display and or concatenate files. Cat can also be used to display line numbers. So let's say I have a really big, long file. User include generally will have some big, long files. argp.h. Okay, let's try that. argp.h. If I do cat on this, that's a lot of lines of text in that file, and sometimes like the compiler will say you've got an error on line 100 and I want to know which line is 100. Generally I would do that in my editor, but if I was at the command line and for whatever reason I wanted to just quickly take a look at line 100, I could say cat-n and then whatever my path is. So cat-n and then the file name, and now it prints it out with line numbers at the beginning, and so I could scroll to line 100 and I could see whatever the problem was with it. Okay, so whoops. So cat-n adds line numbers. We saw that that file was very large, and so if I just do a cat on it, it scrolls by really fast and I gotta scroll back up to take a look through it. If I wanted to look through it one page at a time, I can use what is called a pager. So the command less is one of the most popular pagers. Its name refers to the fact that there used to be an older pager called more. Less is a better one. It allows you to go back and forth within the file instead of just forward. So all you do is type in less and then whatever the path to the file is. So if I want to take a look at the dictionary that's installed on the system, I just type the path to that. So it prints out the first page of text. I can use my arrow keys to move up and down. I can use page up and page down to move up and down. Just like with the man pages, I can type slash and search for a word. If I want to go to the next search result, I press N and so on, and then I can press Q to exit. Now the reason it's the same as the man pages is because when man is displaying a man page, it's using the less pager to display that man page. Okay, so that's the less command. Show the files one page at a time. Sometimes you just want to take a look at the top of a file. For that, you will use the head command. So by default, it's going to print out the first 10 lines of any given file. So I'll say head, user share, dict words, and it gives me the first 10. I guess those are considered to be words in the dictionary. If I want to print out, say, only 3 lines, then I would say head dash whatever number I want to print. So head dash 3, user share, dict words, and now I get only the top 3 lines. Same sort of thing here, except displaying the bottom of the file with the tail command. So if I want to display the bottom 10 lines of the file, tail, user share, dict words, that's the bottom 10. If I want to display only the bottom 3, it would be tail dash whatever the number is. So tail dash 3, dict words. And now I've got the bottom 3 lines. And again, I don't know why these are considered words, but whatever. Okay, so we saw the rm command before in the context of removing directories. Of course, rm can also be used to remove files. So if I've got this ABC file here and I want to remove it, just rm abc. And of course, if you did not do that alias command that I showed you before, it'll just blow it away. It will not confirm it unless you were to explicitly type rm-i. Okay, so be careful. If I want to delete multiple files, just specify all the ones separated by spaces. It gets rid of those. Moving. So moving files and directories around, you're going to use the mv command. So if I wanted to, let's just restore things here. So, okay, let's say I want to move file 2 into directory 1. So it's move source to destination, okay? So I want to move file 2 into directory 1. And now if we take a look at ls, we see file 2 is no longer in there. If I take a look at ls-dir1, we see it now has file 2 within it. If I wanted to move it back, I would say, so here's our tree. If I want to move file 2 back into the current directory, I say move dir1/file2, relative path, right? Space, and then dot. So what you want to move, where you want to move it to. I want to move file 2 into the current directory. That's a special reference, as you may recall. And now file 2 is back. Okay? If I wanted to rename, let's say dir1 to ASN1, a rename is just a move. It's just moving it to a different file name, really. So I could just say move dir1 to ASN1. And now we have it renamed. Now, again, standard disclaimer applies here. Be careful with this command. It will overwrite things. Unless you do move -I to confirm, to go into interactive mode, it will not confirm. It will just, overwrite without warning. So again, I recommend paste in this alias, log out, log back in, and then from then on, whenever there's a situation where move might overwrite something, it will try and confirm it with you. Yep. Sorry, I can't hear. Yell it. Any extension? Yes. Any file. So file extensions don't really matter in Linux, right? I can have, you can see here, I've got file 1 and file 2. It's got no extension. Linux doesn't care. I could change it to file 1 to file1.txt. It doesn't care. Okay? Extensions aren't really as important in Linux as they are in other operating systems. Yeah. Yeah, it doesn't matter. Linux treats it pretty much all the same. As we're going to see later in the course, if you give it a permission to execute, then it'll treat it a bit differently because now I can run that file. But like on Windows, a file is executable if it has the extension .exe. I don't have to have an extension and I can still execute that file. I could call it file 1. As long as it has this executable permission, then I can actually run that file. So we're getting ahead of ourselves. We'll talk about that later in the course. Suffice it to say for now, the file extension on Linux doesn't really matter. Yep. If you want to move it or rename it, that's a good question. So let's think about that for a minute. If I type in, for example, okay, if I type in move file 1 to file 3, what's going to happen, do you guys think? Based on what you see on the screen, what do you think will happen? Yep. It'll rename it. Why do you think that? Right. So what it's saying is, okay, I'm going to move it to file 3. Well, file 3 doesn't already exist. So that person must mean that they want to rename that file to file 3 because it doesn't already exist. Now, if instead I were to type move file 3 to ASN1, what's going to happen now? It's going to move it into there. So what it's doing is it checks first, all right, is that destination a directory that exists? If it is, then it assumes, okay, that must mean that you want to move it into that directory. If it doesn't already exist, then it says, okay, you must be wanting to rename it. Does that make sense? Okay. Okay, yeah. Copying files. Use the cp command. How are we doing here? A few more minutes. So cp command is used to copy. You can copy files or directories. So I can, let's say, do we have any text in here? No, we don't. So let's just put hello into file 2, and then we'll prove that we've copied it by saying copy file 2. So again, it's copy source to destination. Copy file 2 to file 3. I've now made a copy of that into file 3, and you can see it has the same content. Okay? If I try to copy a directory with the cp command, by default, it's not going to work. So if I say copy ASN1 to ASN2, it's going to, well, it tells you what's wrong. You haven't specified the -r flag. This is a directory you're trying to copy, so I'm not going to do it. -r again is recursive. Do you want to copy it recursively? You want to go into that directory and copy all of its files and subdirectories. So that's all you have to do. If you want to copy a directory, you simply say cp-r, whatever the directory is, and what you want to copy it to. Okay, and now you can see, oh, that didn't have anything in it, so that's a bad example. let's do make dir dash p ABC, and we'll do touch a slash F1, B slash F2, sorry, A, B, F2, A, B, C, F3. So we've got a tree here that has a bunch of files and subdirectories. If I want to copy it recursively, I'll simply say cp-r, what I want to copy, where I want to copy it to. So copy A to a directory, I don't know, dir3. And now if I take a look, I've got dir3. If I look in my tree now, dir3 has all of the same subdirectories that A had under it. Okay, so that's a recursive copy. Again, standard rule or standard disclaimer, be careful, it will happily overwrite things. So again, might recommend take this line, copy it in or paste it into your terminal, log out, log back in, and that way every time you type cp, it'll actually run cp-i. And anytime there's a situation where you might be overwriting files, it'll first ask you, are you sure you want to do that? Okay, that's it for the commands that we're going to talk about. Just to wrap things up for the day, I want to quickly talk about keyboard shortcuts in Linux. Keyboard shortcuts really kind of take you to the next level in Linux. One of the reasons you use the command line is because for a lot of tasks, it's a heck of a lot faster, as I said, than taking your mouse and pointing and clicking, once you get proficient with this stuff. One of the ways you do that, and one of the ways you're really fast at the command line, is by knowing and using keyboard shortcuts. So a few common ones that you will see on a Linux system. Control A will take you to the start of the line in a lot of programs. Control E takes you to the end of a line. So, if I'm here and I've got hello world, I can press Control A, that gets me to the start. Control E gets me to the end. You can press the home and end keys. Those will generally work on most Linux systems as well. But sometimes it's just faster, at least on my keyboard. My home and end keys are these little tiny keys at the top. It's just faster and more natural for me to just press Control A and Control E. You can also use Control K to delete from where your cursor is currently located to the end of a line. So let's say I've typed in, I don't know, some big long command, user whatever, and I realize, wait a minute, I don't want to list the contents of user bin. I can use my arrow keys and move over here, and then I can say Control K, and that'll delete to the end of the line. And now I can say, well, I actually wanted to list the contents of /etc or whatever. Okay, so Control deletes to the end of the line. You might have seen that I've been clearing my screen. So I'm doing things like this, and then all of a sudden the screen just clears. You can type the clear command, that works. You can also type Control L, press Control L. Now the cool thing about that is if you've already typed in a command but you haven't yet pressed enter, if I press Control L, it'll clear the screen, but I don't have to retype that command. It's still there at the prompt. I can just now hit enter. These ones are important to remember, Control C and Control D. As a beginner to Linux, you will get stuck in some programs, okay? If you accidentally, like let's say you were trying to view a file and you just typed cat, and now it's just, what's going on? What do I do next? Just press Control C. Control C is one of the universal shortcuts to either interrupt a command or cancel it or quit from it. Okay, so Control C will generally get you out of most things. If that fails, you can also do Control D. Control D inserts what's called the end of file character. And in Linux, that's used in a lot of places either to close off a file or also to exit out of a command. Now, a pro tip is it's way too slow to type a 4-letter word exit to log out. So instead, I can just press Control D, and then I've logged out. And now your life is just so much more efficient. So log out with Control D. Okay, tab completion. Embrace your tab key. This is where you get really fast. You don't type in, cd, user, local, bin, blah, blah, blah. I would type in cd/u, press tab. It completes it for me. I type in L, press tab. Oh, okay, that's ambiguous. It doesn't know which one do I want, so it shows me the options. So I type in one extra character to make it unambiguous, press tab. Now it completes it for me. I type B, press tab, it completes it for me, that sort of thing. It's kind of a contrived example, but the point is I'm not just, slowly typing things. I'm using my tab key as I'm typing all the time. So I might do, I don't know, CD, etc, HTTPD, that sort of thing. I didn't just type all of those characters in. I typed CD/E, press tab, I typed H, press tab, I want to go to conf.d. Okay, it's ambiguous. I press tab again. It shows me what possible options are there. I press one more key to make it unambiguous to say that this is the one I want. Press tab again. Okay, no, it's not unambiguous. So I have to do one more character, and there we go. Okay, so try using your tab key. It'll make you a lot faster as you're navigating around. It works for file names as well. So if you're in the current directory and I want to list the contents of the reset script, I would say cat R, press tab, hit enter, and there we go. That shows you my little reset script. Finally, for some commands, it will even show you what subcommands they take. So you're going to see in the lab the git command. You're going to be using the git command for submitting assignments, and we will take a look at that next week. Sorry, I'm wrapping up. You're going to type git, press tab, and you will see all of the subcommands that the git command takes. Okay, really quickly, just your takeaway for today, you learn Linux by using Linux. You need to sit down, just even for 2 minutes a day, try out these different commands, try to get familiar with them. Now, as you are doing your lab 1, as you're doing your assignment 1, and just throughout the course, I've made a little cheat sheet for you here that covers all of the commands that we've talked about today. So I encourage you, while you're doing your lab or your assignment, have that handy, and that should help you out. Okay? Thank you for your attention. Have a great weekend, and we will see you bright and early on Tuesday.